Hello everybody, what I'm about to show you is our project for this course. The title is Realistic Search Engine Query Log Generation. So I will show you briefly about the background and the algorithm that we use in the project. And also I will show you the current progress on our project. So first of all, why search engine logs are important? You can see the bullet point here. Uh, it is firstly, it is useful for researchers, mostly in the information retrieval area. They can use the search engine logs to simulate the user and search engine iterations, and also they can use these search engine logs to benchmark information retrieval algorithms. The problem that comes to our mind is that there are a lot of search engine logs generated every day. Why do we not use them? Why do we need a tool to generate the search engine logs? Well, the problem is that uh, these search engine logs are not open to the public. You can, because of the privacy issues. I will not go to the detail of the privacy issues. Uh, One example is that there was this time when Wikipedia publishes the anonymous search engine log files, but it turns out that there are people that use these search engine log files to find the identity of the individual who have put in the search engine search log queries. That means basically you can find the identity of the person with the search log queries that he used. So this is a very big privacy issue. In the best case is that we used to have the MSN query log. It is it is open to research and student use, but very recently, I'm not sure if it's very, but recently the MSN search engine logs are also restricted. It is no longer open to the to research and student use either. So that besides this, there are other potential options we can use. You can see the bullet points here. But it turns out that these options, for example, using a librarian system or using MTurk, these options turns out to be they are also hard to find and also either expensive or time consuming, and some of the cases is also a bit in the gray area as well. So if you want to do research or do application in a large scale, this is going to be a problem. It's going to be a problem. So this gives us the idea is that why not we generate the search engine logs ourselves based on the documents? But still, it's hard, and I'll show you how why it is hard. So why this generating search engine logs is hard? Well, essentially, you are simulating user's mind based on the document, but people's mind are hard to simulate. Um, uh, and also, these search engine logs have some characteristics. You can see the bullet point here. Imagine when you are trying to search for something, it is kind of difficult to tell exactly what you are going to put into the search engine. For example, if you want to search for the result of the election, you put in 2006 election. I mean, stuff like that is kind of difficult to put them into a structure. And for the same type of purpose, you may put into different queries. For example, instead of putting 2016 uh, election, put uh, you may put I don't know, Hillary Clinton and Donald Trump, stuff like that, to find the election result. So these are examples of why generating search engine logs is hard. But still, we want to at least look a little bit into the problem and try to make a little bit of contribution. The formulation we have is this. Firstly, we have a corpus containing n documents. This is either a set of crawled web pages or Wikipedia pages. And for now, as I will show you later, we are using the DLBP dataset. And we can assume that the user is looking for some information in the corpus. And also, we want to generate, or that's our goal, we want to generate realistic queries that simulate the user's queries. I will go into more detail in the solution here. Uh, we select M documents from the corpus, meaning that these M documents are the document that we want the user to, that we suppose the user want to find. And we start with the dummy query, and we apply the query on the corpus. And after this iteration, after we apply the query on the corpus, we will have some document, and the document will be ranked, and we can use a query. Well, most probably the target M documents, target M documents, is not the top M documents that are in the result of the query. And then we can use a query expansion method to promote the query so that the rank of the M documents would be increased. This is the key step, and this step is this is where most of the problems occurs, and I will go into more detail in the later presentation. And then we apply the query, this resulting query on the corpus again, and iterate until the M documents rank top. This is kind of like a pseudo feedback, but in this case we had the feedback, which is the target M document. So we keep doing this iteration until the query that we have will give us a result. In that result, the M documents rank the top M in the entire result space. One of the query expansion method that we are using, and this is the main method we are using, is the Rocco algorithm. I think most of you are familiar with the Rocco algorithm. So the Q0 here is the query from the last iteration, and this is D is the relevant document. Well, in our case, this is the M document that we are targeting, and the DK here, well, that was the DJ for the relevant document, and for the DK here, DK represents the non-relevant document, and A, B, C are the three parameters, and this term in the bracket is essentially the centroid of the document if we use the vector space representation for the document. One difficulty is that, as I will mention, another method that we can use is to build a thesaurus for the query expansion. That is, we use some dictionary and to find what are the words that accompanies the word that we put into. For example, we can use the existing vocabulary like the UMLS, or we can automatically derive the thesaurus. Actually, we try to automatically derive this thesaurus, but it turns out that this is pretty much like the Rocco algorithm if we reuse the maximum likelihood algorithm or similar algorithm. So this is so in practice, at least for now, this is not very much used to us. But we may consider I think what potentially can also be done is to use this automatically derived thesaurus to demote the query, that is to take out the words from the query, as I will show you later in the result. So the many words in the query is a problem. As I showed here, can also be used to demote the words in the query. Next slide. This is one of the key answers that we are answering, and we have some results for it. Because we want the query, we want to limit the number of the words in the query. Otherwise, if you really think, using the vector space representation, a query with exactly the same content as the M document would work. If we use a query that has exactly the same content as the M document, If we put in the query, of course, it will give us the M document as the top ranked document, but we do not want that. We want a query, we want to limit the number of the words. I think no sane person will ever put into something a query that is as long as a document to search for it. So we want to limit the number of the words. And also we want to study the effect of the relevant document and the non-relevant document, and study the combination of ROCO algorithm combined with other query expansion methods. The ROCO algorithm actually we implemented the iterative ROCO algorithm, the basic iterative ROCO algorithm, and we're trying different ways to modify it. Another extension is to extend the idea to session-wise queries as indicated in the proposal presentation, as indicated by the Professor Zhai and Chase. For example, what we may want to do is that if we search for a query like cheap flight, we can generate result for cheap hotels as well. Well, this is kind of difficult from the first stage of the project, but this is something that we are working on right now. And for example, if you search for Hillary Clinton, you can get the result for Donald Trump. Or if and this is basically, it try to simulate the session-wise queries instead of one single query. This might be useful for application in research, and this might be interesting to the research community as well, to the session-wise queries. And also, in this generation, one of the potential problems are listed here. For the first stage of these potential problems are for the first stage of the project, which is to generate the relevant queries. You can look at it. This is basically saying, what if we have a document that is very far away from each other, based on the vector space model, how we deal with them, and that we are doing experiment on. Essentially, if you think that if you have 20 documents, and you want a query that give you the result of these 20 document, but among them 10 are closely clustered, another 10 is closely clustered. This is kind of difficult to simulate. And also, in an extreme case, 19 of them are closely clustered, but one is not as relevant. And in a more extreme case, these M documents they are mutually orthogonal, or they are mutually irrelevant. How do we represent that? But this is the things that we are currently doing experiment on. And if these previously targets can be finished, we will try to extend it to this. We can extend it to the query to have a grammar structure, and also simulate the log distributions as well. For example, what percentage is the long queries and what percentage is the short queries. Yeah, if it works, it can be of many use. For example, generate large-scale search engine queries, and for domains that are not feasible in the real world. For the evaluation, we can collect some real queries and their top K result from Google, and also we can use manpower. We can look at a few documents and really think what query that we may use to represent this K document, and that we can use that to evaluate our result. This is so next I will show you the current result of the project. I will show you a part of the code and some of the result that we get. Now I will mention briefly about our implementation and some of the results that we are having right now. So the dataset that we're using is the DBLP dataset, which is the same as the dataset that we use in the assignment 5. So each paragraph represents a abstract, a very conference paper, but now we are using this abstract as the document, and we want to generate the queries for a pre-specified document. And this is the our main application. I will not go into the very much detail of the code, but I will only show you generally what the code is about. So firstly, we take into a query, a dummy query that, for example, now I'm providing 5 dummy queries as a starter query, and the files that we want to generate the queries for are pre-specified, and we put into so we put these queries into the search. This is also part of the search function, and also and then use the ROCL algorithm here, and this for relevance feedback. So we specify a number of iterations and use this relevance feedback using the ROCL algorithm to expand the queries based on the rank of the document, and based on from that we so for each iteration we get an update on the queries based on the rank of the document using the ROCL algorithm. Uh, so this is the intermediate result that we get for the for the 5 starter queries, and we're now working on the intermediate result to get the final queries. If you are watching this right now, that means that this part is not fully finished yet. Uh, uh, but this is very close to being done. And for the evaluation, we are now using the manpower evaluation. That is, we will generate 20 queries, not 20 queries. So we will look at the field document, and we will manually generate the queries on ourselves, on our own for the document, and then compare the queries that is automatically generated using our algorithm, and compare that queries with the queries that we manually generated for the document, for the M document we want. So if you are watching this right now, that means something is not fully finished yet, but within very but yeah, within, but this is very close to being done.